The channel not only explains technology, it designs the future. If you want AI, data science, and real-world tech mastery, welcome to Technical Professor.
Everyone, welcome back to Technical Professor. So in this lecture, we are going to discuss about statistics for machine learning. So in previous lecture, we learned how to machine learning store data using linear algebra and handle uncertainty using probability. So today we learn equally important statistics, and statistics help us understand data before we build models. Without statistics, even best ML algorithm will fail. So let's learn it. So importance of statistics. So understanding statistics is essential for machine learning as it helps us to analyze data and reduce noise and evaluate models effectively, ultimately enhancing decision making process. So why machine learning statistics? So statistics answer very important questions. So what does my data look like? Is my data reliable, or are there any outliers? Which feature really matters? So machine learning models learn from data, and statistics tell whether the data makes sense or not. All right. Okay. So let's learn about population versus sample. So a population means the entire group. Okay. All right. So for example, all customers of Amazon, that is population. Okay. All customers of Nokia, all customers of Apple, all customers of Flipkart. These all are population. All right. And what is sample? Oh, sample is smaller subset taken from population. In ML, we usually work with samples, but not fully population. So because collecting all data is expensive or impossible. All right. Okay. So a good sample helps us make accurate prediction about the population. All right. So now we are going to understand types of data. Now, numerical versus categorical. What are that? So there are two main type of data. So first one is numerical, and second one is categorical. So numerical data represent measure quantities such as height or temperature, while category data consists of discrete like colors or names, effective how we analyze informations. So let's learn about numerical data. I will give the examples. Numerical numbers are we can measure like height, temperature, salary. These are all kind of numerical data. And what are the categorical data? In categorical data, labels or groups like color, example, gender, a country. Uh, different data type require different ML techniques. Okay. Discrete versus continuous. Discrete data include distinct values such as the number of students, where continuous data can get any value with a range like height or weight, allowing for detailed analysis. All right. So now we are going to understand uh, descriptive statistics. So in discrete, there is countable values, but in continuous, values within range. Okay. So regression models usually deals with continuous data, where classification often use discrete data. Okay. So now we are going to understand descriptive statistics. So let's start it. So descriptive statistics summarizes data in simple way. The first one is mean, second one is median, third one is mode. All right. So they help us understand the central tendency of data. All right. So mean is the average of data set calculated by summing all the values divided by count. It is simple. Okay? Like 1 to 10, we will calculate all by 10 by summing all 1 plus 10. Okay. Median is the middle value in sorted data set. They are divided into two equal halves. So you already done in 9, 10 classes. So and more also that is most appear most frequently like 1, 2, 2, 2. 2 is the mode. Okay. All right. So the mean is calculated by the summing all data points and divided by total number of entries that is provide a center value that represent the data set effectively. Okay. But what is median there? And median is middle value after sorting data. It divided data set into two equal halves. So median is robust to outliers, which make it very useful in skew data set. Okay. So measure of spreads. So if your data contain extreme values, like mean can be misleading. So in such case, median give a better add up typical value, and mode shows common patterns. Good ML start with choosing the right statistics. So measure of spread. Okay, so now we are going to understand what is range, what is variance, and what is standard deviation. Okay, so what is range? So range is the difference between highest and lowest. It's a simple formula you can remember. For example, there are numbers 1, 2, 6, 8. What is range here? If I have to calculate range, what is range there? What is highest? 8. Lowest? 1. Range is 7. Okay. So it gives a quick idea of variability, but it doesn't tell how data is distributed between. And what is variance? Variance measure how much data points differ from the mean. So high variance mean data is spread out, and low variance mean data is concentrated. And in ML, high variance can indicate complexity and risk. All right. So now we are going to understand variance. Variance is a fundamental concept in statistics that is represented as spread of data and around the mean. So understanding variance help in grasping how data variability affecting machine learning models. Okay. So high variance means data is spread out. If low, it means concentrated. In ML, high variance can indicate high complexity and risk. All right, so now we are going to understand standard deviation. So standard deviation is square root of variance. All right, standard deviation variance is used in feature scaling. Where is it used? In feature scaling and outlier detection and model evaluation. So now we are going to understand data distribution. So distribution shows shape of the data. So it tells whether data is symmetrical, skewed, concentrated, or spread out. So understanding distribution helps choose the right ML model. So now we are going to understand normal distribution. All right. So normal distribution is look like bell curve. So many real world uh, data set approximately follow this pattern. So several ML algorithm assume data is normally distributed. So which is why this concept is important. So it is fundamental and statistic characterized by its bell curve shape, where the data is clustered around the mean, emphasizing its importance in machine learning assumptions. All right, so now we are going to understand how it is Z score. Z equal to x minus mu by sigma. It is indicate how many standard deviation over a data point it is from the mean. It is crucial tool for outright detection. It helps identifying usually high or low values in data set. All right, so now statistics used throughout the ML pipeline. So feature selection, scaling, normalization, model evaluation. So statistics improve both accuracy and stability. So outliers are data points which are different significantly from other, often leading to misleading interpretation machine learning model and affecting the output analysis. So correlation measure the relationship between two variables, indicating how change in one effective can another. It is crucial for understanding data pattern in machine learning. So correlation was the causation. So the difference between correlation and causation is crucial in statistics. Misinterpreting these concepts can lead to conclusion and poor decision making in machine learning models. Alright, so now we have to understand what is covariance. So covariance is a statistic measure that indicate the degree to which a variable change together, and at providing insights to the relationship between them and crucial for understanding data in machine learning. Alright, so statistical interference is the essential in machine learning to estimate population parameter, understand data variability, and test hypotheses help to make informed decisions based on data analysis. So sample technique also important. So sampling techniques is crucial in statistics for machine learning. Random sampling help reduce bias and ensure representative data while recognizing potential biases essential for expected modeling. Bias and variance is critical in machine learning. So balancing errors from model assumption and data variability. So understanding this helps build robust effective models for accurate predictions. So data leakage, why data leakage occurs? So it leakage occurs when information from outside the training. So data set is used to create the model, leading to our optimistic performance result that can mislead understanding and expectations. So statistics in ML models, that is feature selection, scaling. Okay, so scaling ensure all contributes equally. So without scaling, feature with the large dominates, large value dominate, and distance based model perform poorly. So scaling leads to better generalization. Okay, so it helps to enhance model accuracy and reduce complexity, and leading to more effectively so machine learning outcomes. So scaling may ensure that the features contribute equal to the distance calculation and preventing feature with large ranges from this for the proportion influencer model. So what are real world applications? So understanding statistics is essential for effective machine modeling, but this ensure accurate interpretation and helps the prediction power of the model we utilize. So what are the common mistakes? So many beginners overtook the importance of distribution in data analysis. So understanding the shape and spread of data can significantly impact model performance and lead to better predictions. Okay. So blind averages so rely solely on average can be misleading. So beginner often miss the variability in data, which can skew result and misinform. Decisions thus impact overall accuracy and reliability. So now what is summary of today's lecture? So let's understand. And statistics explain data behavior and guide feature selection and scaling. Alright, so it improve ML model performance. Alright, so in conclusion, understanding is the vital for effective machine learning. So we will explore optimization and gradient descent in next session. So in this next lecture, we will learn optimization and gradient descent. So the process that actually train machine learning models. So if these lectures help you under, understand statistics better, so like the video and comment optimization for next lecture. Thank you so much for watching this video.